So far we discussed how to find reminders by using a reminder. As I said, using reminder theorem for finding the reminders is simpler than finding the reminders by using a division procedure. Now, one of the application of reminder theorem is factor theorem. This is also very important concept in polynomials. Factor theorem. Factor theorem. This is one of the application of reminder theorem. Let us see here one example. Is 2 will go in 7? No, it will go in 3 times. 6 and remainder is 1. This is 7 is dividend, divisor, quotient and remainder. What is the remainder here? 1. Now take 6 as dividend and 2 as a divisor. How many times 2 will go in 6? 3 times. 6, 0. What is the remainder we got here? 0. Now what is the difference between these two divisions? In this division we got 1 as the remainder, here we got 0 as the remainder. Here this 2 is just a divisor, but here this 2 is also called a factor. This divisor is also called a factor. Why this divisor is also called a factor of 6? Since you got remainder as 0. If remainder is 0, then this divisor is called a factor. Okay, when a divisor become factor, if you get 0 as the remainder, then this divisor is called a factor. If divisor divides exactly without leaving any remainder, then it is called factor. Okay, when this divisor become factor, when you get a 0 as the remainder, is 2 is remainder factor here? In this case, is 2 is the factor? No. Why 2 is not a factor? Since we got 1 as the remainder, non-zero number you got as remainder. That's why 2 is not a factor here, but 2 is here factor. This is the simple concept about factor theorem. If remainder equal to 0, then the divisor become factor. Now apply this principle to remainder theorem. What is a remainder theorem? As we learned before, f of x is equal to x plus a into q of x plus f of minus a. This is a remainder theorem. This is a dividend, divisor, quotient and remainder. In this remainder theorem, is x plus a is a factor? Is x plus a is a factor? No. Why? Because we got f of minus a as the remainder. X plus a, f of x, q of x and remainder is f of e. Is x plus a is a factor of f of x? No. Why? Since we got f of minus a is the remainder. If f of minus a equal to 0, the remainder becomes 0, then what will happen? The remainder becomes 0, then x plus a is a factor of f of x. If f of minus a is equal to 0. If f of minus a equal to 0, what you will get? F of x is equal to x plus a into q of x plus 0. Plus 0 we need not to write. Therefore, f of x is splitted as the product of two polynomials. F of x is splitted as the product of two polynomials. Therefore, here x plus a is called a factor. Okay, when a divisor become factor here, when remainder is 0. If remainder becomes 0, then the divisor become factor. What is the remainder here? F of minus a equal to 0. If f of minus a equal to 0, then x plus a is a factor. If f of a equal to 0, then what is the factor? F of a equal to 0. Make this procedure reverse. Minus plus. Here plus, then minus. Then f of a is the factor. Is it clear? If f of minus a equal to 0, then x plus a is a factor. If f of a equal to 0, then x minus a, because a is the 0 of x minus a. Here f minus a is the 0 of x plus a. This is called factor theorem. See, what is the statement of the factor theorem? F of x is any polynomial whose degree is greater than or equal to 1. F of x is any polynomial whose degree is greater than or equal to 1, and f of minus a equal to 0. F of minus a equal to 0, then x plus a is a factor of f of x. This is a factor theorem. What is the factor theorem? F of x is any polynomial whose degree is greater than or equal to 1, and f of minus a equal to 0, then x plus a is a factor of f of x. As I said, what is this f of minus a? This is a remainder when f of x is divided by x plus a. F of minus a is the remainder. If the remainder becomes 0, then the divisor become factor, as we learned before. Therefore, this is called a statement of the factor theorem. Let us prove it. According to the remainder theorem, we got f of x is equal to x plus a into q of x plus f of minus a. This is a remainder theorem. What is the remainder theorem? F of x is equal to x plus a into q of x plus f of minus a. In place of f of minus a, you keep equal to 0. Substitute in place of f of minus a 0. What you will get? F of x is equal to x plus a into q of x. This value is 0. If 0 is value, we need not to write. Therefore, f of x is split as the product of two factors. See, x plus a into q of x. Therefore, this each one is called a factor of f of x. Therefore, x plus a is a factor of f of x. 6 can be written as 2 into 3. Therefore, 2 is called factor of 6, or 3 is called factor of 6. In the same way, f of x is divided as x plus a into q of x. Then x plus a is called a factor of f of x. Is it clear? F of x is called, x plus a is called factor of f of x. If f of minus a equal to 0, should not forget this condition. When x plus a become factor, if f of minus a equal to 0. This is called a factor theorem. What is the factor theorem? F of x is a polynomial whose degree is greater than or equal to 1, and f of minus a equal to 0. F of minus a is a factor. If f of minus a is a remainder. If a remainder equal to 0, then this divisor become factor of f of x. Is it clear? Now, if f of 1 equal to 0, what is the factor? F of 1 equal to 0. What is the factor? Say, f of 1 equal to 0, 1 is the 0 of x minus 1. Therefore, f x minus 1 is a factor of f of x. F of a equal to 0. What is the factor of f of x? What is the factor? A is a 0 of x minus a. A is 0 of x minus a. Make the procedure reverse. If x minus a is a factor, divisor or polynomial, a is 0. If a is 0, then x minus a is the divisor. Okay, if f of a equal to 0, then x minus a is a factor of f of x. Likewise, f of minus a equal to 0, what is the factor? X plus a. F of 2 equal to 0, what is the factor? Plus minus x minus 2. F of minus 3 equal to 0, what is the factor? Minus, that is plus there. X plus 3 is the factor. F of 4 equal to 0, then x minus 4 is a factor. Is it clear? Again, if x plus 2 is a factor, then what is the condition? X plus 2 is a factor. What is the condition? As I said, x plus 2 is a factor. What is the remainder? F of minus 2. The remainder should be equal to 0. F of minus 2 equal to 0. This is the condition. If x plus 2 is a factor, f of minus 2 equal to 0. Don't forget to keep equal to 0. The remainder equal to 0, then only this divisor become factor. If x minus 3 is a factor, what is the condition? What is 0 of x minus 3? F of 3. F of 3 equal to 0. X plus 4. What is the condition? Plus 4. 0 of x plus 4 is minus 4. That is f of minus 4 equal to 0. When we should keep equal to zeros? When these divisors are factors. If the divisors are factors, then the remainders equal to zeros. Is it clear? Now we'll do one problem based on this concept. Check. X plus 1 is factor of, x plus 1 is factor of x power 4 plus 3x cube plus 3x square plus x plus 1. Check, is x plus 1 is a factor of x power 4 plus 3x cube plus 3x square plus x plus 1. How can you find x plus, how can you check x plus 1 is a factor of this given polynomial? Very simple. If you divide any polynomial by first degree polynomial, if you get 0 as the remainder, 0 as the remainder, then the divisor become factor. Assume this is as f of x power 4 plus 3x cube plus 3x square plus x plus 1. Find x plus 1. Therefore, 0 of x plus 1 is minus 1. Find the value of f of minus 1. Remainder. What is the remainder of x plus 1? F of minus 1. Now, in place of x, substitute minus 1. Minus 1 whole power 4 plus 3 into minus 1 whole cube plus 3 into minus 1 whole square plus minus 1 plus 1. Minus power 4. Minus power 4 is minus power is even. The minus become plus 1. Minus power is odd. The minus remains minus. Minus into plus minus 3. Now, minus 1 whole square. Minus power is even. Minus even, minus become plus. Plus into plus. Plus 3 into 1, 3. Minus in plus into minus. Minus plus 1. Minus 3 plus 3 cancel. Minus 1 plus 1 cancel. Equal to 1. Did you get a remainder as 0? No. If remainder is not equal to 0, then the divisor is not a factor. Therefore, here x plus 1 is not a factor of f of x. For this given polynomial, x plus 1 is not a factor. Why x plus 1 is not a factor? Because here we got 1 as the remainder, non-zero number. If you get 0 as the remainder, then x plus 1 become a factor. Let us see one more example. Is x plus 1 is factor of x power 4 minus 5x cube plus 5x square minus plus 5x minus 6. Find is x plus 1 is a factor of x power 4 minus 5x cube plus 5x square plus 5x minus 6. Assume this is as f of x. Since x plus 1 is a divisor, therefore remainder is x plus 1, f of minus 1. In place of x, substitute minus 1 whole cube. In place of x, substitute minus 1, 5 into minus 1 whole, this is power 4, sorry, cube plus 5 into minus 1 whole square plus 5 into minus 1 minus 6. Minus 1 whole power 4 minus power even plus now minus whole power odd minus into minus plus 5 ones are 5 minus 1 whole square become plus into plus plus 5 ones are 5, 1 into minus 5, minus 5 minus 6, plus 5 minus 5 cancel, 1 plus 5 6, minus 6 0. How much remainder we got? 0. If 0 as the remainder, then this x plus 1 become a factor. Therefore, x plus 1 is factor of f of x. Therefore, if you want to check if a first degree polynomial is a factor of a given polynomial or not, just you find the remainder and find the remainder. If it equal to 0, then it is a factor. If it is not equal to 0, it is not a factor. Very simple. The remainder is 0, then the divisor is a factor. If it is not equal to 0, divisor is not a factor. Is it clear?